Alrighty, folks. So we're going to keep working our way through here, our analyzing trig, our analytical trig, and we're going to look at now how to solve trig equations. So we're still going to use our algebra. We're still going to use our trig identities like we did before, but we're going to actually use the trig and combine it with the unit circle to actually figure out actual equations. So the first thing we're looking for is we're always looking for x or theta or alpha. In other words, we're always looking for angles. When you're solving a trig equation, you're solving for angles. All right, so we're always going to have some value of angles. And when you get your angle, when we solve for whatever that angle is, realize the angles we're finding are just between 0 to 2 pi. Remember that there's an infinite number of them, so we're going to always add 2 pi over n onto every single answer. And after that, we'll eventually look at how to link things together, but we'll do that. We'll start looking at that as we go through here. And then all our rules of algebra still go together. Get all the variables on one side and then the ratios on the other side. If you're dealing with a quadratic, set it equal to 0. So all these things are still going to be the same thing as if we're solving any normal equations, just we're using trig now. But here is the biggest thing to remember. And we're not going to be dealing much with this today. We will deal with it more tomorrow. So today is kind of like simple trig equations, and then tomorrow will be a little bit more harder trig equations. Sometimes when you see a trig equation, people look and say, oh, if I got a cosine on both sides, I'll divide both sides by cosine, cross that off, and that'll cross off, and I'm left with 1 equals cosine. Friends, cannot do that. You lose a root when you do that. You lose a root when you do that. If you have a problem like that, it's better to do something like this to it, where you're going to set one side equal to 0 by moving that cosine x to the other side. And I want you to see how we end up losing a root by doing that. So we get our cosine x, and then if I wanted to keep factoring this here, I'd go ahead and I'd factor it. So what term goes into both these here? And I could have factored out a cosine x here, and that would have left me with a cosine x minus 1 equals 0, or a cosine of x minus 1. Set them both equal to 0, you get 0 equals cosine x. So this is that 0 product property here. Cosine of x minus 1. So cosine of x equals 1. That would have been the correct way. So when we do this correctly, yeah, that cosine x equals 1 we would have got. But notice what would have happened here. By canceling it out, if we would have canceled out the cosine x by dividing out, we would have lost this cosine x equals 0. We would have lost answers, which we got to make sure that we don't do that. All right. Cosine x is not lost. It is transformed. All right. Oops, it went right there. You lost a solution. Okay. Now, what you can do, and on this second one, notice the difference here. What you are allowed to do is if you divide by cosine, if you just turn it into a different trig function, sine and cosine, that is tangent. That's okay. We didn't lose anything. We didn't lose any solutions. We just turned it, transformed it into a different trig function. And this won't come into play here, but checking for extraneous, that'll come into play tomorrow when we look at some of those. So we're going to be solving some simple trig equations, and then tomorrow we'll come back and we'll solve a little bit more advanced ones. All right. So let's start off here. Tangent of x equals 0. So we're looking for when on our graph, when on our unit circle, is the tangent of x equal to 0. So whenever we're doing this, we're always thinking of our unit circle. Tangent of x is the same thing as y over x, if you're looking at coordinates. So y over x equals to 0. In order for that to happen, it's when y equals 0. So that's going to happen here, it could happen here. These are the 2 points where my y value is 0. So when tangent of x equals 0, we could say then that that's when x equals 0 plus 2 pi n, or x equals pi plus 2 pi n. So that's a good answer. That'll give me like 4 out of 5 points, 3 out of 4 points, whatever. But we want to always, whenever possible, we want to try to link them so we can write our solution in as few numbers as possible. So if I'm looking at this here, whenever you're dealing with your solutions, always try to figure out how far away they are from each other. And if they have rotational symmetry, so they're symmetrical, then we can reduce it down there. So for instance, this answer right here, both these numbers are pi away. So I could have linked these two together as one answer. I could have linked them together as 0 plus 1 pi n. I didn't have to have two separate solutions. I could have wrote it as one solution. This right here is called a linked solution. And we want to try to link them whenever we can. Sometimes they're just not going to link together. That's okay. If it doesn't work out, it doesn't work out. But if we can, we want to be able to link them together in as many or as few of actual answers as possible. So if I could take 4 answers and get it down to 1 or 2, great. Do whatever you can. All right, friends, why don't you guys go and pause the video and see how you guys do with this next one here. All right, so I have secant x minus root 2 equals 0. So that means secant x equals root 2. Now I'm hoping at this point you guys can actually know when secant is root 2. If you don't, that's okay. Maybe you're not quite there yet. That's fine. If you need to, go ahead and do your reciprocal for it. So secant of x is 1 over root 2, which is root 2 over 2. So that's what we're looking for. When is our angle root 2 over 2? When is secant going to be root 2 over 2? Or when is cosine going to be root 2 over 2? When is secant root 2? That's going to happen out here at pi over 4. And it'll happen again here at 7 pi over 4. These would be on the unit circle when those things would take place. So pi over 4 and 7 pi over 4. So then we look and say, all right, are these rotationally symmetrical? In other words, can I spin it the same thing to get different things? Well, these right here, these two solutions are 2 pi over 4 away. Whereas these are 6 pi over 4 away. Now I'm hoping you guys can just look at the solutions and realize it's not symmetrical. But if not, you can always just kind of look at how far away they are from each other. So 2 pi could go from 7 pi to 1 pi. Well, 6 pi if you go 1 pi to 7 pi. So they're not symmetrical, so we cannot link these two. We have to write these as two separate solutions. And a majority of the time, guys, a lot of the time you can't link them. And that's totally good. If you can, though, you always need to check to see if it's possible. If it's possible, we need to link them. All right. So, got a little practice at that here. Let's make it a little bit more now. Now we're going to get into some algebra. So see if you guys could treat this like an algebra equation and see is it possible for you guys to be able to solve it. All right, so let me show you what I got here. I got 2 sine x cosine x. And then for me, I would subtract root 3 sine x from both sides. So subtract root 3 sine x from both sides. And when you did that, you get 2 sine x cosine x minus root 3 sine x. So I'm going to get everything on the same side. So whenever, if I can't automatically solve, but then I get everything over to the same side, and then I try to see, is there a way that I can use algebra? Or in this case, can I factor it? Is there something that I could factor out? In this case, I notice I could bring a sine x out, and that would leave me as with 2 cosine x minus root 3. So sine x times 2 cosine x minus root 3. So once we're there, we're going to go ahead now and set both things equal to 0. So set both our factors equal to 0. So sine x equals 0, and then 2 cosine x minus root 3 equals 0, which means that cosine x is root 3 over 2. So these are what we're playing with here. Sine of x equals 0, cosine of x equals root 3 over 2. So when does that happen? Sine x equals 0. Well, again, sine is y, so y equals 0 at 0 and pi. Notice we've already seen that we can link these together, but I'm not going to do that yet. I'm going to wait, because there might be better ways to do it. Cosine of root 3 over 2, that could be here at 7 pi over 6. Could be here at 11 pi over 6. So pi over 6 and 11 pi over 6. So what we're going to do then is we're going to put them all on 1. Put them all on 1 and try to figure out, is there a way that I can somehow spin all these to make them be, so is there any sort of symmetry that can go in between them all? I already know that I can do 0 and pi together, but is there any other way that I could put the rest of them together? So I have pi over 6, 0, 11 pi over 6. I have pi. And we're trying to figure out, is there a way that I can link them together? So let's see here. This would be 5 pi over 6. 5 pi over 6. And if I skip the 0 and do these two, I'd get 2 pi over 6 away. So that didn't work. So those aren't symmetrical. So it looks like the only type of symmetry that I have then would be going from 0 to pi and pi to 0. In which case, I'll link those two together and I'll leave the 2 pi over 6s as their own answer. So when we're doing this, we write the original answers just so we can all see them. So sine of x, we had x equals 0 plus 2 pi n. X equals pi plus 2 pi n. We had pi over 6 was an answer. And we had 11 pi over 6 as an answer. So when I'm looking at putting them together here, what links up? Well, these are the only two that linked up. So because those linked up, I'm going to write those as one, but I'll leave the other two as separate. So when I link those together, I get 0 plus pi n. So whenever possible, link them up. If you can. If you can't, don't worry about it. Just do that as much as you can. You want to try to link them up so that they are separate answers. And x equals 11 pi over 6. All right. Well, let's keep going here. Let's do a little bit more. We're only going to do a few more today. And then we'll do a lot tomorrow. We're kind of practicing this a little bit more. So now, try number 4 and see what you guys can do with it. All right. Go for it. Okay, let's see here. I'll tell you what, some of you guys probably move the 1 to the other side, and that works. Just make sure that you don't lose a plus or minus. But what I actually see here is I see this more as a difference of 2 squares. A minus b, a plus b. So what I usually do on these is I'll usually just go ahead and factor them. So cosine squared x minus 1 equals 0. I would have factored it. Cosine x minus 1 and cosine x plus 1. So we set them equal to 0. So cosine x is 1. Cosine x plus 1 equals 0. So that means cosine x equals a negative 1. All right, so here we go. Got to graph it here. When is cosine positive 1? Let's see here. Positive 1, that's going to be right here. Negative 1 will be right here. So that's at 0. And this is at pi. And then what we want to do is we then want to see, can we link them together? Is it possible to link these together? If we can, we want to go ahead and try that. And again, we've already kind of linked these two together already a couple times, but just so we see them again. 0 and pi do link together. So I'm not going to write them as two different answers. I'm going to write it as one answer because they are symmetrical. They have 180-degree rotational symmetry. So first up, I would write them as two separate answers to begin with. X equals 0 plus 2 pi n. And x equals pi plus 2 pi n. And then, friends, I would link them. So x equals pi plus pi n. All right, why don't you guys try the 2 sine squared x plus 1 equals 3. See what you come up with, and then we'll take a little gander at it. Go for it. All right, let's see it. Let's see how you guys did there. Okay, so I'm dealing with quadratic. So I got to set one side equal to 0. So I'm going to move the 3 sine x over to where the sine is. The sine squared x plus 1 is. Always want to keep that sine squared x positive. So that's kind of what we're looking at right here. So, and again, like we said before with trig identities, a lot of times I'll usually come over here and I just try to factor it like normal to see, all right, well, I don't want the trig stuff to get in the way. I just change sign or whatever the trig function is and just use the one letter and then try to see, all right, can I factor this? Is it factorable? In this case, 2s minus 1 and s minus 1 would factor that. So then I'd come back over here and I'd change them back to this is factorable. So 2 sine minus 1 and sine minus 1. So I'm going to set each one equal to 0. Let's see, I forgot my x's. Don't want to do that. Unless they live in Texas, and then that's a different story. All right, so sine x minus 1. So we have sine x equals 1/2. And sine x equals a positive 1. So we're going to try to figure out when is sine x equal to 1/2. So we're going back to our unit circle again. And then sine x equal to 1. All right, so sine x equal to 1/2. That'd be down here and over here. So those values, that would be at pi over 6 and 5 pi over 6. Well, I know these are both on the same side of the x-axis, so there can't be any symmetry there. All right, sine equals 1. Well, that's going to be up here on the y-axis. All three of my points are on the same side of the x-axis. So that means when I go and I throw all these together here, there is not going to be any sort of symmetry, rotational symmetry at all, because I don't have any solutions. I don't have any solutions on the negative side of the x-axis. So because of that, there won't be any linking of solutions when I get all done with this one. So I have pi over 6, pi over 2, and 5 pi over 6. So there is no linking solutions. I'm just going to go ahead and write all these and write them as just one answer. All right, so we have x equals pi over 6 plus 2 pi n. X equals pi over 2 plus 2 pi n. And x equals 5 pi over 6 plus 2 pi n. All right, friends. Well, I got one more for you. One more for you guys to try here. See if I can't get to it. There we are. Why don't you guys go ahead and pause the video and try 4 cosine squared x minus 3. And then we'll do a bunch more of these tomorrow on the second part to this assignment, where we just look at some more advanced type ones that get a little bit tougher, not much tougher, but a little bit tougher. But until then, go ahead and give those a try and see what you can do. All right, let's see how you did. I'm going to scroll up a little bit more here. So this one doesn't really factor out, so I'm not going to worry about trying to factor it out. Instead, I'm going to solve to get cosine by itself. So like cosine squared x, or 4 cosine squared x equals 3. Cosine squared x equals 3 over 4. And then I'm going to do my square roots. So I'm going to get rid of my square by taking the square root. Don't forget the plus or minus. I don't need to put the 4 under with the plus or minus in front of it since the 3 has it. So I end up with cosine x equals a plus or minus root 3 over 2. So I'm going to break this up into 2 separate cosines. I have cosine x equals a positive root 3 over 2. And I have a cosine x equals a negative root 3 over 2. So I'm going to take a look at where these values are. Definitely not do that. Let's do this instead. So when do these values exist? Cosine equals a positive root 3 over 2. That would be over here and here. So pi over 6 and 11 pi over 6. Negative root 3 over 2, that'd be this way and that way. So we get those angles. So 5 pi over 6 and 7 pi over 6. So our answers that we got then are x equals pi over 6 plus 2 pi n. We have 5 pi over 6 plus 2 pi n. We had 7 pi. And last but not least, we also had 11 pi. So what we're going to need to do now, friends, is that one more time, we got to figure out, do any of these link up? So I'm going to take them all and figure out, do I have any that are going to have some rotational symmetry? Any rotational symmetry anywhere? So here we go. We got pi over 6. I had 5 pi over 6. 7 pi over 6. And 11 pi over 6. And let's see here. I'll tell you what, here's what I'm seeing. I see the pi over 6 and the 7 pi over 6. I see that as being 6 pi over 6 away. Otherwise known as pi away. And likewise, I can bring it back here. These can be linked up. Also, if you notice, I can bring these two together. So this would be a positive 6 pi over 6. Which is the same thing as positive pi away. So that means these could link up together as well. So I actually can link these things up here. So I had, let's link the green ones together. And we had pi over 6 plus pi n. And we had the blue ones that we were able to link together. So 5 pi over 6 plus pi n. Well, friends, as you can see kind of down below there, as we're getting ourselves to it, we're going to have more solving equations next on our next video. So we'll talk about these tomorrow in class, and we'll spend a little more time about it. And then tomorrow night, we'll have the second part of this lesson, and we will finish it off. So have a great rest of your afternoon, evening, and I will see you guys in the morning. Take care.